So we are going to do some review or just a summary about the reduced echelon form. And like what I said, the note will be put on online, and there are lots of numbers. So probably it's not recommended that you are taking the notes by yourself. Okay. Or you can just take the part that is you think it is essential. Okay, so we are going to talk about the reduced echelon form. Okay, so remember we are doing the row operations. So what we have done here is actually called the reduced row echelon form because we are doing the row operations. And in most of the software or in many places, because this name is just way too long, so people will write it as RREF. Okay, so in the future, whenever you see or when I write RREF, it means the reduced row echelon form. And in some cases, it is called the row echelon form, but we will talk about that later. Okay, so I want to emphasize again what are the requirements of the reduced echelon form, an RREF. Okay, the first requirement is that it has to be stair-like. It looks like a stair. And so it means that you are walking from here and keep going down and go down and go down. And more than that, the stair should be something that you can walk on that. So it's not going to be a stair like go up, go down, and go down too much and keep going. This is not called a stair. This is called a cliff. Okay, so stair means that you go down one and go down one and go down one, stair-like. Okay. And secondly, for each row, if it is stair-like, then you can see all the corners here. It is the leftmost element in each row. And if it is corresponding to a linear system, then these are called the leading variable, right? Remember, we have lots of variables, and this is the first one. So it is called the leading variables. And so the second requirement is that if you find a leading term, then everything below that should be 0. This is the second requirement. Now the third one and the fourth one is not actually required for the reduced echelon form. It's not required for the echelon form, but it is required for the reduced one. So for the reduced echelon form, you also want it to be 0 above. Okay, you have been solving lots of equations before. It's okay to just find the equation that looks like this. It is good enough. But if you want to make it more simpler, then you can kill all these things above. Okay, and then you will become the reduced echelon form. Okay, I have the last color and also the last one to say. And sorry, some of the color is very hard to see, but I will try to make it bigger. Okay, the leading coefficients. The coefficient, 系数, the coefficient of the leading term is equal to 1. Okay, so for example, this one, you can write it as 2x minus 6y, but most of the time you will just write it as 1x minus 3y, right? So you can rescale the equation so that it has a leading coefficient equal to 1. So I will mark these two conditions. Okay, these two conditions are actually not required. By a row echelon form. Okay, so if you are just looking for a row echelon form, then you don't really need to do the green part and the yellow part. All you need is try to make it stair-like and make it 0 below. Okay, so you can make a photo if you like, but like what I say, it is very hard to copy all the numbers on the board. And the reason that we are using the program to generate this is also because of this. You see, we have maybe eight equations, and I forgot, maybe 14 variables, and it is just tedious, 就是很复杂的, tedious to write such a big things. But if you only do some small one, then it is a bit hard to see the structure. Okay, so now we have the example of such a row-reduced echelon form. Then we are going to see some non-examples. They are not RREF. Okay, so again, I generate some of the examples later, and so let's see what are they and what is the condition missing. Okay, so this is not a reduced echelon form. Try to spot the reason. Okay, you see it has to be stair-like, and so far it is good. And so far it is fine. You just go to the right until you can go down. And now up to here, you feel like this is even worse than the Caliph. This is just Taroko, I guess. Okay, so it is not stair-like. Okay, so this one is not a reduced echelon form. If you have a row that is all 0, then you should put it at the bottom. Or if you have a row that is shorter than the previous one, then you should put it at the bottom. You cannot put this 1 minus 3 here, because otherwise it will look like it does not look like a stair. Okay, it has to be the longest one, the second longest, and shorter and shorter and shorter, and the 0 should be at the bottom. By doing this process, it can help you to see what is the meaning of the concept. This is very important for doing mathematics. You look at the concept and look at some examples. Okay, now you know, yes, this is a reduced echelon form. But then look at some of the non-examples, 反面的例子, and checks that, okay, what is the missing condition? Why it is not work? It is not working. Okay, now I have one more non-examples. Actually, I have quite a lot of non-examples. Okay, now you see this one is kind of what I mentioned before. This is actually not stair-like, and also it is not zero below. Okay, so here is the problem. Whenever you see a leading variable, then it is the king at that position. It has to kill everything above and below. And so it is impossible to have two kings at the same column. Okay, so this is not zero below. And again, you understand what's going on, because if you have an equation like this, you have another equation like this, then you are going to do some row operation to kill the next one, right? So it is impossible for this to exist. So again, it is not an RREF. Okay, so like what I said, I have quite a bunch of examples. Now what's going on with this one? This time, it is stair-like. Okay, so far it is fine, everything is good. But now you notice that, which color? I guess it is the green color. Okay, if you look at this leading term, and it should be zero here. Okay, so that's trouble. So this one is not an RREF, not an RREF, but is an REF. Okay, it is a row echelon form, but it is just not yet reduced to the simplest form. And the reason it is not zero above. So you know it's okay to solve the equation like this, but sometimes you really want it to be a bit simpler. And it's not a requirement, but if you want it to be the simplest, then you will kill this one also. Like what I said, these examples will be available online, so I will probably be too fast if you are writing these numbers. This is the last one, I guess. Yeah, there's no next page. So again, you see it is stair-like. It is not a problem. And it kills everything below. If you have here, then it kills everything below, kill everything above, everything below, everything above. And it works for every leading terms. But the problem is this one, okay? The coefficient is not equal to 1. Okay, so again, this is not RREF, but it is REF. And the reason is the leading coefficient is not equal to 1. Okay, so I want to point out some of the terminologies. I guess I can copy this one. Okay, so whenever you see this, you can imagine that it is the coefficient or coefficient of coefficient of some equations. So I want to point out some of the terminologies. Let's say this is x1, x2, you see a lot, right? That's why we use the computer. Okay, so we have done something before. Moving to the right, leftmost, these are the important part. Okay. These are the important part, and you can draw something like this. These are the leading terms. Okay, so the leading variables. It is the leftmost variable in each equation. Okay, so in this case, it is like x1, x1, x3, and x8, x11, x13. And free variables, it is everything else. Okay, so in this case, we have x2 is not leading, x4 is not, x5, 6, 7, 9. It's a lot. Okay. Now I want to introduce the last term. It's called a pivot. Pivot 就支点的意思 or 轴心 okay. And pivots is basically the leading variables, but it records the index 它的逐标 indices of the leading variable. So in this case, it is 1, 3, 8, 11, and 13.